everyone, this is Dr. Zach. Today in AP Calculus, we're going to determine where our function is increasing or decreasing. We're also going to apply the first derivative test to find our relative extrema of a function. So let's get started. While completing your lesson preview, you may recall that the velocity function is the derivative of your distance. So we have our little velocity function was 2t minus 7. Perhaps you made a sign chart to help recall where your function is positive or negative. Now, please know that the sign chart is not the answer. You must use complete sentences to answer the questions that are asked. The sentences are the valuable part of this problem. We're going to extend the idea of where functions are increasing and decreasing today. So your function is increasing where your derivative is positive. Your function is decreasing when your derivative is negative. Your function is called strictly monotonic on an interval if it is strictly increasing or decreasing on that interval. The way that we're going to test for whether a function is increasing or decreasing is we're going to look at our first derivatives. The first derivative greater than 0 tells us that the function is increasing, or your slopes are positive. The derivative is less than 0 tells you your function is decreasing. And where your derivative is equal to 0, those are going to be the places where your function is constant. So as we take a look at this picture, we can see that the derivative is related to the slope of the function. When your derivative is negative, your function decreases. Where the derivative is constant, your function has a derivative equal to 0, and where your derivative is positive, your function is increasing. So as we look at these little cubic functions, what you'll notice is that there are horizontal tangent lines where the functions switch from being increasing to decreasing. At times, there might be a horizontal tangent line, but it doesn't switch where the function was increasing if your function is strictly monotonic. And at other times, there are multiple places where your function is constant or intervals. And if that's true, this one is not considered strictly monotonic. For example 1, we're going to determine where a function is increasing or decreasing. To do that, we want to find our critical numbers. So if we find the derivative of f of x, f prime of x, using our chain rule, 2, keep our inside, times the derivative of the inside, which is 2x. When we take this function and set it equal to 0, notice that we have a nice factorable function. We have 4x times x minus 3 times x plus 3. You have 3 critical numbers, x equals 0, x equals 3, x equals negative 3. So if I want to know where my function is increasing and decreasing, I'm going to make a nice little sign chart to help figure this out. On the sign chart, I'll put my critical numbers. I'm going to label this as f prime of x because we're describing where the derivative is positive or negative. To the left of negative 3, our derivative is negative. We know it's 0 at negative 3. Between negative 3 and 0, the function derivative is positive, then 0. It's going to switch back to negative and then become positive. Now, if you're questioning where the positives and negatives came from, you could simply substitute values on that interval into your factored function, and you will have whether or not the function is positive or negative. Now, the nice thing about the sign chart is it gives us a graphic of what f of x is doing. F of x, because it was negative, was decreasing, flat, and then increasing. It was also increasing, flat, and then decreasing. And then at 3, it's decreasing, flat, and increasing. Now, from this graphic, we get a lot of information, and we have to state the information in sentences. So we might say f of x is increasing on negative 3 to 0, union 3 to infinity. F of x is decreasing on negative infinity to negative 3, union 0 to 3. You can also see from the graphic where we have relative extrema. There is a relative max at x equals 0. You have a nice little graphic to tell you that. At f at 0, and it equals, when you substitute, 0. We also know that there are relative mins at f of negative 3, which actually equals f at 3, and they both equal 0. So you have a relative min and a relative max in this problem. You could sketch a graph of this using the sign chart that we drew. Now, the sign chart, as I said, is a tool. It is not the actual answer. Oh, sorry, f at 0 is actually 81. Let's fill that in. So when we graph this, plot the points you know, which will be your critical points. We're going to go up to 81. Not really, count by tens. We also know that at 3, the answer is 0, and at negative 3, the answer is 0. The function had to be decreasing to get to where it was flat. You can draw the min and maxes in because you already have nice little pictures to help remember what's going on. Then it was increasing, decreasing, and we are going to infinity on the. So by completing the sign chart, we have completed an analysis for the first derivative test. The first derivative test will tell us where our relative mins and maxes occur and where our function is increasing and decreasing. For example 2, we want to determine where the function is increasing and decreasing. So let's find a derivative first. G prime of x is going to be equal to 3/5 times x squared minus 9 to the negative 2/5 multiplied by 2x. Nice little chain rule for us. Simplify the expression so that it's easier to use. We're going to rewrite it as 6x over 5 times our x squared minus 9 to the 2/5. So again, you can see we have multiple critical numbers. The critical numbers occur where your derivative equals 0. So that's going to be where x equals 0. And where your derivative does not exist. Well, the derivative does not exist at x equals 3 and x equals negative 3. However, those points are in our domain. So we've found 3 critical numbers. Now that we have the critical numbers, we should make a sign chart. And a sign chart is going to help us analyze where g of x is increasing or decreasing. So we have our critical numbers 0, negative 3, and 3. We know that the derivative is 0 at 0, but we also know that the derivative does not exist at negative 3 and at 3. So we do not have horizontal tangent lines there. We have vertical tangent lines or cusps there. But we're also told that the function is, well, we should do a sign analysis. To the left of negative 3, we have a negative in the numerator and a positive in your denominator, which tells us g prime of x is negative. Between negative 3 and 0, we're still negative. Between 0 and 3, we have a positive divided by a positive, which is still a positive. And of course, to the right of 3, it's a positive as well. So g of x is decreasing more, increasing, and then increasing more. So g of x is decreasing on negative infinity to negative 3. We do not include negative 3 because it has a vertical tangent line there. Union negative 3 to 0. G of x is increasing on 0 to 3, union 3 to positive infinity. Now, what about relative extrema? We don't have a relative extrema at -3, but the first derivative test, let's look, we're going from decreasing to increasing. We have a relative min at g of 0, and g of 0 is equal to -9 and 3/5. We have no relative max. For example 3, we're going to take a look at h of x. Now, I'm going to use a quotient rule. You don't have to, but if we use the quotient rule, we have h prime of x is equal to, here's the bottom, times the derivative of the top, so we have 5x to the 4th, minus the top part of the function, times the derivative of the bottom, which is your 2x, over your x to the 4th. We're going to clean it up a little bit. This gives us 5x to the 6th, minus 2x to the 6th, plus 2x, add like terms, and we are going to be left with a nice little 3x to the 6th plus 2x divided by x to the 4th. When we do a little bit of factoring, that gives us 3x to the 5th plus 2 over x to the 3rd. So we have a couple of critical numbers. We have a critical number at x equals -2/3 to the 1/5 power, and it looks like x equals 0. But wait, x equals 0 is not in your domain, so it does not exist. That's where you have a vertical asymptote. When I make a sign chart to help understand what's happening with h of x and h prime of x, I'm going to include the 0 in my sign chart because often or sometimes the signs will change where the vertical asymptotes occur. So we write in -2/3 to the 1/5 power. Now let's do a sign analysis. To the left of -2/3 to the 1/5 power, we will have a negative divided by a negative, which makes it positive. In between -2/3 and 0, it's still going to be a negative. After we hit our vertical asymptote, we will have positive values. So if we look at what's happening at the critical number, the function was increasing and then decreasing. So that's going to be a relative max. So let's see what we have here. What we know is that h of x is increasing on -infinity to -2/3 to the 1/5 power, union 0 to positive infinity. We also know that h of x is decreasing on -2/3 to the 1/5 power all the way to 0. Now, just because it's fun, did you notice that there's an oblique asymptote? If you did your long division, you have x to the 5th minus 1 over x squared simplifies to become x to the 3rd plus 1 over x minus 1 over x squared, and you have an oblique asymptote at y equals x to the 3rd. So if we try to graph this, notice we also have a vertical asymptote, which you have been practicing graphing this. Let's put our vertical asymptote in at the 0. Remember the bones of the graph. We're going to place our cubic as the oblique asymptote. There we go. Remember to always follow the asymptote. If we were on the left side of 0, so we're taking the limit as x goes to 0 from the left side of h of x, you're going to get looks like a negative infinity. On the right side, the limit as your x goes to positive infinity, 0 from the right side of h of x, gives you a negative infinity. So we're heading down the asymptote to the left side and the right side of the 0. But we also know we need to follow the asymptote, and we have a critical number at negative 2/3 to the 1/5 power. When you substitute in, you do get a negative. I'm not too concerned about what that actual value is. And figure out what the rest of your graph looks like. Remember, just follow those asymptotes and you are set. So the first derivative test was very helpful with our graphing because we know that we have a relative max at f of negative 2/3 to the 1/5 power. So here we have some guidelines for determining where a function is increasing or decreasing, and a little bit more information about that first derivative test. So if f prime of x is changing from negative to positive, then you have a relative minimum. So that was negative to positive. If f prime of x is changing from positive to negative, you have a relative maximum. I suggest drawing those little graphics to help figure out what's going on. And if f prime of x is positive on both sides of c or negative on both sides of c, then f at c is neither a relative min or a relative max. Now, example 4, we're going to determine the relative extrema of our trig function, because we can never forget those trig functions. First, we find the derivative. F prime of x is going to be equal to the cosine of x minus, actually positive, root 3 sine of x. So we know that we're going to have a critical number when the derivative is equal to 0. So 0 equals the cosine of x plus root 3 sine of x. Let's rearrange the problem just a little bit and get the cosine of x is equal to negative root 3 sine of x, which then tells us that the sine of x divided by the cosine of x, ooh, that tangent, is negative 1 over root 3. And if you don't like a tangent function, then you can think of cotangent. So where does the sine over cosine equal? If you have to rewrite it, I like to rewrite it as negative 1/2 over root 3 over 2. So where is the sine equal to 1/2 and the cosine equal to root 3 over 2? Those values are going to be when x equals 5 pi over 6, 11 pi over 6, and many, many more multiples. Essentially, x is going to be equal to 5 pi over 6 plus or minus pi k, where k is equal to 0, plus or minus 1, plus or minus 2, and so forth. Now, if we make a sign chart, think about what's going to happen. F prime of x in our sign chart is going to have multiple places where we switch signs. We have negative pi over 6 and 5 pi over 6. Put in your 11 pi over 6. And maybe even 17 pi over 6. Get a good idea of what's going on. So we will have, think about your values, a negative, 0, positive, a negative, 0, positive, and more zeros. And this goes on and on. So you can see you have multiple relative extrema. You will have mins, you will have maxes in multiple places. You will have relative maxes when x is equal to 5 pi over 6. Notice it's skipping every other one. So plus or minus 2 or plus 2 pi k, where k is equal to 0, plus or minus 1, plus or minus 2. And you will have relative mins where x is equal to negative pi over 6 plus 2 pi k, where k is 0, plus or minus 1, plus or minus 2. So quite a few relative extrema with your trig functions. So example 5. This time, you have all the information given to you, and you have to draw a sketch of what's going on. So I love these problems. I think of these as clue problems. So first, you're given some values. F at 0 is equal to -5. So we have 0, -5. That's just some sort of point. You were also told that 2 gives you -2. So this is going to help us graph it. All right, now, the derivative is less than 0 for x is less than 0. So we're going to make a sign chart. And in the sign chart, we know we have to think about x is less than 0, x is greater than 0, and also what's happening between 0 and 2. So let's put in 0, let's put in 2. We know that the derivative is negative on the left side of 0 and the right side of 2, and that it is positive in between. So what's that tell you about f of x? We know that f of x is decreasing, then increasing, and then decreasing. So we could draw decreasing then increasing symbol and a nice little increasing and then decreasing symbol. So you can tell where your relative min and max are from this information. Let's put together what we know. We know that 0 goes to -5. We also know that 2 goes to -2. Now at 0, we're going to draw this little scoop. There's your relative minimum. And at 2, we're going to draw a relative maximum. So that's essentially all we have, except we do know that we're decreasing to get to the minimum, then we increase to get to the maximum, and decrease thereafter. So the function we have seems to be a cubic polynomial. For your lesson practice, you're going to state where the functions are increasing and decreasing. You're also going to determine the critical numbers and determine the intervals where the function is increasing and decreasing, as well as identifying all of the extrema. For questions 58 and 60, I want you to sketch the derivative of each of the functions. So think about where your derivative is increasing, or excuse me, where your function is increasing or decreasing, and make a table of values like we were working on in the earlier problems. Finish up this assignment, and you have a great day.